Paul Pedersen. I'm the deputy CTO of Tengen. Tengen is a company that develops and provides commercial support for MongoDB. I thought it'd be interesting for this particular meeting to describe the application of MongoDB at the CERN CMS experiment. First, I need to acknowledge that everything in this talk is basically summarized from a paper, an excellent paper, and you can download and read. So context, this is about the LHC. I love this thing, and I've been following it. Was really delighted to discover that MongoDB is really being used to solve physics problems. So what is the LHC? It's this gigantic ring. It's 27 kilometers in circumference, about from here to San Francisco Airport. This monster runs at 40 megahertz every second. They actually extract about 100 events. One event is about a megabyte raw data that gets pushed in a block onto disk. And this story is really about how the metadata that allows discovery and analysis of all these raw data blocks is managed using MongoDB. What is a CMS? CMS is one of the key experiments that it's a detector that is sitting at the intersection point of these two tubes in which you have high velocity protons circulating. What CMS stands for is compact muon solenoid. It's a giant magnet, basically. Muons are just like electrons, except heavy. They grew up in Middle America. You need a honking big magnet to bend these. You want to detect the direction and momentum. It turns out to be a very sensitive probe of what sort of interactions are taking place during these proton annihilations. So CMS experiment is a collaboration, 3,000 scientists, 183 institutions, 38 countries. This is not a politically correct spiel. This is a requirement. This is about having a truly distributed, transparent, distributed computational system. What it's being used for is basic physics. It was used in the discovery of the Higgs boson, which was announced, and then also for work on validating or invalidating theories which involve extra dimensions, grand unification, supersymmetry, and dark matter. Stay tuned. So this is about big data. How big are these data? It's, as I said, meg per event, 100 extracted per second. This thing runs day and night, month after month, year after year. It's all piling up. So estimate I've seen is about 2 to 6 petabytes raw data per year, 500 gig of metadata per year. They stress tested Mongo, found that it ran, well enclosing their performance envelope, 20K doc inserts, raw data, 100K random reads per second. On a SSD configuration, we've measured up to 100K random reads or point updates per second. So what is the CMS data aggregation system? It's basically a federation system. There are lots of miscellaneous data inputs. You've got the run summaries, luminosity database, physics experiment export, site database, and the database publication system, which is basically index of the event metadata. So this is a metadata management system. The central component is the DAS core, which basically analyzes queries coming in through the REST interface from 183 institutions, 38 countries, and so forth. It does a query parsing analysis. It then defines a workflow. It checks the mapping database to determine how to translate the query syntax into the keys required for these foreign data sources. It will then also check the cache. Perhaps it already has raw data, doesn't need to go to the original data source, or it may have a completed answer. The merge database are the aggregated results. So there's a raw result cache, and then there's an aggregated complete result. So if you just want to see the same answer again, it's in the merge database. If you want some of the building blocks, they sit in the raw data cache. And then there's a DAS analytics database, which contains data about the performance of the query, the timing and so forth, for the purposes of query optimization and possible prefetch strategies. So that all four of those are running on MongoDB. And I think this is a pretty typical application of MongoDB. I mean, you've got tons of raw data, big disk blocks that contain blobs or whatever, and it's perfectly fine to put those into a key value store but you want to do data discovery, complex queries around the metadata, and you need something with a more powerful query syntax. That's it. So you can read the slide. My time's up. This is quoted from their presentation about why they chose MongoDB.